Hi there, I'm Nils, and I'm going to be walking you through the entire process of how to install a sub-panel. A sub-panel is just a circuit breaker box or an electrical panel that's used in conjunction with an existing main panel. Just a couple of housekeeping items. It's important that you work with a certified and licensed electrician on this entire process. Typically, you are going to need to pull a permit, so check with your city for local codes and ordinances to make sure that you're doing everything up to code and properly. Also, in my case, I've been working with an electrician to make sure that we have all of the correct information here. It's all verified and I'm doing everything up to code. With that in mind, this video is intended as a help for it, so definitely do your homework first. Don't just rely exclusively on the content that you see here. I'll have a link in the description to my website where I've written up a complete article with charts, diagrams, and everything you need to help with that. Let's start off with space requirements. In order to install a sub panel, there are 3 measurements you need to be aware of. Number 1, you need 36 inches or 3 feet of space in front of the panel to work with. Number 2, you need to be able to have 30 inches across the panel. There needs to be plenty of room for the door to open, for you to access it or do whatever needs to be done in here. And then finally, you need up to 78 inches of height here. This is the analogy I saw that I like. If there's a telephone booth put up against the wall, you need to make sure that this sits somewhere within that wall of the telephone booth. The next part you have to make sure is that you have sufficient power to pull from in the main panel that you're connecting to. In my case, the main that I've got is actually right here. So you can see this huge wire right here. Just on the other side of this wall is the main for my house. And I'll just be pulling from that right there, just a couple feet away. Now, not everyone will be so close, and I fully understand that, but you do need to make sure that there's enough panel space for you to put a new circuit breaker to run your new sub panel. This is basically just going to be connected to that via a simple set of wires, kind of like this one, and then we'll make sure that everything goes to the right place. When it comes time to select your actual panel that you'll be using, there are several things to consider. The first one is what brand you want to use. My house uses Square D Homeline. It's a very common setup here in the United States, but there are other options too, like Leviton, Siemens, Eaton, and more. But if you do have one already in your home, you might want to use the same one. Maybe update to something like the Square D Homeline, for example. I've chosen a 2040 panel. That means I've got 20 rows here to work with, which means I should be able to install up to 40 circuit breakers. I'm actually converting my garage into a shop, and this is part of that process. And I'm going to be installing a 70 amp box here. Now, this box is rated for up to 125 amps, and I'm only going to be feeding 70, but I'm wiring it so that it can handle at least 90 or 100 amps, just in case I need to upgrade it down the line. If you're somewhere in a detached space from the panel that you're feeding from, then you're probably going to need a main breaker. This box, for example, doesn't come with a main breaker, and I don't need one in my case. The next thing to consider in the planning phase of this is what gauge of cable and what type of cable you're going to be running from the main source to the panel itself. As you saw before, I just have a few feet to run, so it's not as big a deal, but you have a few different options. Over here, we have an all-in-one cable. So there's SER cable and there's tray cable, and both of those have a jacket that encloses all of the cables within them. They come in multiple sizes, multiple gauges, and multiple counts of wiring. But typically for a sub panel, you're going to need 4 wires altogether. First one is you're going to need your set of HOTS. You're going to need 2 120 volt lines coming in to your bars down here or right here. And then the third one you're going to need is a neutral, and that goes up top here. And then the last one is a ground. So it's a 4-wire setup. Now, what gets a little interesting here is that you don't typically actually have to have the same gauge for your ground as you do the other 3. Just to make sure I'm very future-proof on this, is I'm running 2 HOTS and a neutral, and then a 4-gauge ground, and that should give me all the power and bandwidth that I need both now and in the future. So you want to consider whether you do an all-in-one cable like this, like the SER or the tray cable. And in my case, I'm actually opting to go with what's called THHN. And that THHN allows me to feed it through conduit, which I'm going to do entirely on the outside of the structure here. I can run right through those. It's a little more flexible. Consider if you're going to have to run any of this through the studs. I've got 2x4 framing here, so I can't just run one of these guys through it. By code, since this is a load-bearing wall, I can only cut a hole up to 40% of the depth of these, which really isn't enough space for me to run a thick cable like this. The other factor that you need to look at is if you are using conduit like I am, you need to make sure that you have a conduit that's thick enough to account for the amount of wire going in it. Typically, you can only fill it up to about 40%, which leaves room for some flexibility and maneuverability in there. Now, there is a cool app that you can get that's totally free. It's called the Southwire Wire Fill Calc. I'll double check that, and if I'm wrong, I'll put that on the screen here. You can put in what size conduit you're using, what type of conduit you're using, and then what kinds of wires and how many you're putting in of each, and it will give give you a rating on that. In my case, I'm gonna end up using 1-inch EMT, and I'm gonna run that, and it's gonna be almost completely up to the 40%. I usually like to give it more space, but I'm having a hard time sourcing 1 1/4 or 1.5 inch, and the 1 inch is still sufficient, so that's what I'll be using in my situation. There are a couple of things that are a little bit specific to my situation, and I want you to know what those are so that you can calculate if you need to do those on your situation or not. The first one is, you can see right behind me, I have my ground, and I have my ground rod going down. This is called a UFR, and it's going into the concrete, and this is actually the ground for my entire house. So I'm actually going to tap off of this rather than feed my ground from the panel back here. Since this is right here and it's on this side of the wall, I may as well use it. And again, that's what allows me to put the 3 2-gauge wires into a 1-inch pipe, because I don't have to add that 4th ground wire in my specific case. The other thing that's a little bit different, you may notice some of these studs are very close to one another. Typically studs are going to be 16 inches on center, in some cases 24, and in some cases like this, 12 or maybe even a little bit less. That's because whoever built this house, they decided to do it that way, but that creates some problems when most panels are about 14 1/4 wide. So that makes it tough to install. So what I've done is I've reframed all of this, and this is load bearing, so I had to put jack studs, headers, the whole 9 yards. So a lot of you will have just 16-inch on center studs, and you can slide that panel right in. And keep in mind, if that's not an option, you can surface mount a sub panel. If you do so, you want to put some plywood on the back of it and fasten that plywood to the studs, and then fasten your panel to the plywood. So just keep in mind, all situations are going to be a little bit different. That's what I'm working with, and that's why you might see things here look a little different than they are at your house or your business. Okay, thanks for bearing with me through all that. There is a lot that you do need to consider and research and understand before you jump into this. Now, at this point, I'm going to start working on the project itself, and I'll just walk you through the entire thing as we go. We've talked about a lot of the decisions already that were made, so now let's get cutting, installing, and getting this thing put in. The first thing I do here is use the tape measure to find out exactly where this box needs to be placed. Obviously, I've got some framing in place to consider, but I want to make sure that I'm meeting code as far as the space requirements that we talked about earlier. And then I'm also looking at how far away the panel is from the existing outside panel, and I'm using the main feed as a reference point to figure out exactly where this new one will go so that I can line up the exterior conduit that I'm going to be installing. Something to keep in mind with each of these projects is that you want to leave at least some open space either on the sides or the top or bottom. The more open space you have on the sides of the panel, top or bottom, sides, any of those sides, the more it's going to allow you to use the knockouts. If you don't do that, if you frame the whole thing in completely, you're going to leave yourself in a bit of a bind. And one thing I wish I would have done a little differently here is to actually frame this out a little bit lower so that I could leave the bottom open and the top open. But as you can see right here, it's really just the top that I'm going to be working with. I wanted to have everything flowing through the central knockout as far as the source wires, my 2 hots and my neutral. So in order to do that, I used to drill a hole right through from where this was placed, right through to the exterior, and then I was able to line that up. Once I had that lined up, I could use a drill bit to cut a hole to the right size, and I made sure to check the hole saw size against the connectors that I would be using, and then was able to drill all the way through. In my case, you could see I had to drill through stucco, some exterior boarding, some OSB, and in the middle there's some chicken wire, basically some wire mesh that I had to cut through, and that definitely did a number on my drill bit. Because of that, this hole dozer bit, this hole saw, was pretty much destroyed. With the hole in place, I was able to put my LB conduit body inside the hole from the outside, and that gives me access to basically a 90-degree turn in here. Then heading back inside, I needed to figure out how best to mount this based on the thickness of the wall. So I had some couplers, I had some nipples, and then I finally, not at this early stage, and then I finished off with what's called a chase nipple later on, and that allows me to be able to pull all of the wiring through without any sharp edges or anything to rub on. When you're working with the knockouts in the box, just make sure to only take out as much as you need. They're pretty easy to remove. You can just use any hard surface to tap them off a little bit, and then just use some pliers to shake it free. And with that, I had a beautiful fit for the sub panel, and I was ready to move on to the next step. Next, I needed to cut the 1-inch conduit to size, and I wasn't sure exactly what that length would be until I got everything test measured. So I put everything in place. I'm using rain-tight connectors here to make sure that I don't have any precipitation getting inside the run, and then I got my 17-inch measurement, and then I decided to use just a metal blade on a hacksaw to be able to cut that to size. You always want to cut a little long. I know I wear shirts sometimes that say I only measure once, but I usually do measure twice. It's kind of a joke. But then I wanted to make sure I had a little long in case I needed to cut it shorter later. Make sure to ream out the ends so that you don't have any sharp bits of metal inside your conduit. As far as connecting to my main panel, I opened it up just to make sure that everything was looking good and that there was an area that I could drill a hole into without disturbing anything. The last thing we want to do is to drill a hole into some of the wires in there. That could wreak all kinds of havoc. As for drilling the hole itself, I picked up a set of these fairly inexpensive hole saws that are meant for drilling through steel, stainless steel, or plastic, and they're really just perfectly made for drilling into an electrical panel. In fact, you can see the image on the bottom right of the packaging that shows exactly that, and this worked out really well. With the hole in place, I was able to do a proper test fit to see how this would work out, and it turns out my 17-inch measurement was a bit long, so I did need to take about an inch off, and then with that, I was able to snug everything into place and then tighten all my rain-tight fittings down. I love using this set of Klein offset lock nut wrench tools to make it really easy to tighten those rings, because otherwise you have to use a screwdriver and tap it or find some other way, but these just grab right onto it and make light work of it. I then used my channel locks to tighten everything down a little bit more just to make sure it was completely snug and this conduit was ready to go. Next up, I installed that chase nipple that I referred to earlier that has the nice soft edge on it, and then started getting my measurements for exactly how far I needed this to stick out. Now, I'm going to have my panel sticking out quite a bit further than most other people because in this shop, I'm actually going to layer the entire walls with both OSB and 5/8 inch drywall. So it's going to be a little over an inch in depth, so I needed to get that measurement just right on all four corners before installing it. Now, as a result of that, I couldn't use the knockouts, which are supplied in the box, for mounting it on the sides. I had to actually drill my own and then install it that way, but that worked out just fine. And now I've got a nice even standout all the way around. Next up is the fun part, and that is feeding the wires through. Now, these 2-gauge wires are pretty rigid. They're kind of hard to move into position, but I wanted to get everything ready. So I just stripped off about 1/2 inch of wire at the end of each one. And to do that, there's a couple of ways. You can use a blade and just very carefully and lightly score that and then pull the end off, or you can use the wire cutters themselves, which I have built into my strippers, and then just score around that way and pull it off. Either way should work, but what we want to avoid here is cutting too deep and fracturing any of the wires inside the cable. Carefully measure out exactly how much wire you're going to need for everything, and always give yourself a little extra room to play with. So this is really just a matter of fitting 3 separate wires through here. And again, I'm kind of maxing out this 1-inch conduit here, but I was able, with a lot of finagling and back and forth, to get this done. I found it helpful to connect everything on the sub panel, but not connect anything on the source panel just yet. I don't want to bring any power into here just yet. I just want to get it ready so that when I want to, everything's at the right length. Once I had my lengths approximately cut in place and then the ends of them stripped, I decided to connect them up to the 70 amp breaker that would be feeding the indoor sub panel. I did not connect the breaker. I just got the wires connected into it so that when I was ready, I could connect that to my source panel and flip on the power. With my 2-gauge wires in place inside the box, I used some electrical tape to mark the neutral and the second hot with white and red respectively. Now you'll need to install the bus bars that come with your panel. These are for the grounds. You can place these anywhere you want in the panel as long as the holes line up, and you'll see that there's some little studs that protrude from the back of the box that you can use to line them up, or you can just use the 2 holes inside there, and I prefer to do that so that there are 2 screws fastening each bus bar to the panel. The 2 hots and the neutral were already connected, but I didn't have the ground connected, so I connected that to the rod that was right next to it, the UFER we talked about earlier, and then I was ready to connect it to the panel itself. So I made sure to use a metal connector inside a knockout on the top, and then brought that ground in. Before turning the power on to any of this or connecting it all the way to the source, I decided to install these service entrance covers over the 2 hots, and that just makes sure that I have everything covered up, because right now everything is very exposed. So this keeps me protected, and I'm going to leave them in there permanently, and that will help me or anybody who works on this in the future to not have those exposed. Now for the moment of truth. Outside on my source panel, I'm uninstalling the 20 amp circuit breaker that was powering the single line that goes into my garage, and I'm replacing that with the new 70 amp circuit breaker, but you'll notice I'm leaving it in the off position right now while I check everything. While that 70 amp circuit breaker is still off and no power is coming into the sub panel, it's time for me to run my first home run, or my first line, from the new sub panel out to what I'm going to connect it to, which is basically just the old line of the garage. This will power a couple of outlets and then the garage door opener itself. For the purpose of this video, I won't be getting into all the details for how to connect this up, because this is more of a separate topic, but generally speaking, I'm going to strip the sheathing off the wires, separate everything out, measure it, and then mark them all down to where they need to be. I'm going to connect my ground to my ground bus bar, my neutral to my neutral bus bar, and then the black in this case, which is the hot, I'll connect that directly to a 20 amp circuit breaker. I also have a secondary one because this is 12.3 Romex, and I'm just letting that second one kind of hang out in the box for now because I may run a 240 volt on that one if I want to later. Now I'm also installing this circuit breaker on the bottom right, which is a little bit unusual because this is a temporary one. So I'm just kind of leaving this separate just to indicate that this will be functional, but it's temporary. Okay, so at this point I have connected one 20 amp breaker to the new sub panel. We have everything here going into the main panel, the source panel, but it's not flipped on the 70 amp breaker outside. So if I flip that one on and then flip this one on, this connects to the outlet over here, the receptacle, and this is a GFCI. This should be ready to go and will power everything else in the garage that used to be powered on the old panel. So, or the outside panel by itself. Fingers crossed. Let's see how this goes. Okay, we now have power to the box. So now I'm going to switch this on. We now have power to the line, and check it out. We also now have a green light and 124 volts AC coming through. So that was a success. We now have a dialed in and ready to go sub panel that's fully functional. That's pretty rad. Now the hard part is done. We have power. Everything is wired up just as it should be. It's working perfectly. And that again is kind of the turning point of this entire install. We just have a few steps left to finish up. We're definitely not done at this point. So the next thing we want to do is to install our sticker that comes with this that talks about the torque ratings for each of the lugs and screws inside the panel. So I'm going to apply this inside the box on one of the sides where it's not likely to get covered up, and then I'll go through and we're actually going to torque down each of these lugs. I only have a few to handle here, which is pretty nice, but I'm using this guy right here. This is a torque screwdriver. These can be purchased pretty inexpensively. I'll put links in the description where you can get one of these on Amazon for right now. They're about 40 to 45 bucks. That may change when you see this video. Klein makes some, then those are like 300 bucks. They get pretty pricey, but I found that this one does a pretty great job for me. So I'll be torquing each of these down to the right specifications, and then after that we'll be ready to put the panel on just after we do a final inspection to make sure everything looks clean and ready to cover up. As per the specifications directly on the Square D Homeline circuit breaker, this requires 36 inch-pounds of torque. When using the torque screwdriver, basically you just turn this thing until it gives out, and when it gives out it'll just loosen up and you know it'll click as well, and that means you know you've got it to the appropriate torque rating. I can pretty quickly adjust the torque that it's going to exert just by turning the handle, pull down and turn, get it to the right setting, and then use it. The bus bars inside this panel require 20 inch-pounds of torque, so I'm going to fasten each of those down as required. And finally, the larger slotted screws, which would be the neutral and the two hots plus the ground, those each require 50 pounds of torque, so that's what I'm applying to those. Again, these are specifics for my situation, so make sure to check the manufacturer's recommendations for the sub panel that you're using. With everything wired up and torqued down appropriately, I wanted to make sure that the entire panel was totally clean. You cannot have anything else in this panel. You don't want to have any flammable items, obviously, but anything else. I've cleaned out the bottom of it, and then that extra second hot, the red wire that you see over on the right, I've got a WAGO on there to terminate that. It's not connected to anything on the panel or on the other end. It's just there for when I want to use it later, and so it's okay to have those terminated inside the panel so long as they're not connected to anything. Before putting on the cover, I decided to put just a couple of open circuit breakers because the panel comes with the top two slots knocked out already. Rather than leave those open, I just put these in as temporary placeholders so no one can put their fingers inside those open slots. Speaking of open slots, I had to knock out the bottom right one, which I was using, and that's pretty easy to do. You just put a little pressure on the panel and then grab it from the back and then rock it free. So this panel is now complete. The sub panel is installed. Everything's looking good except for one little thing, and this is kind of annoying, but the manufacturer made this with 4 extra slots down here, even though there's no place on the board beneath it for those to accommodate any circuit breakers. So thinking it was the bottom one, I knocked that one out, and now that's not up to code. I need to put a filler plate in there, which I'll have to go purchase and do. But other than that, this thing is ready to to go. I actually have a couple of empty ones in here just for the moment. I'll be filling these in later today, because now that I've got this panel ready, I can start running all of the electrical wires I need for my garage shop here. So that is the point of this. I'm gonna run lots of wires in here. I've got my connectors going in here, and I'll be using all metal ones everywhere in this box just to make it easier to work with in the future. And then everything I'm doing in here is going to be as future-proof as possible. Now, there's a lot that we covered today. There's a lot that you want to check out, not only with the National Electric Code, but also with your local code. That could be in your city, your county, or your state, depending on where you are. So be sure to check that out as well. Now, I've got a lot of helpful resources on my website to help you out with all of this, including a dedicated article with all of the products and tools that you saw in this video, as well as some of the gauges and charts that you're going to need to figure out what to use for your particular application, and then step-by-step instructions of the entire thing. Again, use the link in the description below to click on that if you want to go check that out, and that will help walk you through the entire process. If you have any other questions or anything, feel free to leave those in the comments below. If I missed anything or you saw a better way to do something, again, help us out with the comments below, and that will help everybody to do a little bit of a better job. My name is Nils with Learn to DIY. Thanks for watching.